Hey everybody, welcome back. So today we're going to be talking about angles. Now hopefully today is mostly going to be a review, and just in case you're wondering why angles, well remember from last time we're talking about periodic functions, right? Functions that have this repeating phenomenon. And angles have this really built in, or at least it's built into them, this sort of repeating phenomenon as well. So consider this example. Okay, so I have an angle here, I'm calling it theta, and let's suppose that theta is measured in degrees. If we take this angle and we just rotate another 360 degrees, notice that we would end up at the same spot. Okay, and this is true enough. If you take an angle and you rotate enough, eventually you'll come back to the same place. So angles have this natural repeatingness that we want to, again, model things in real life that have this repeatingness. Okay. So let's go ahead and get into it. All right, so firstly, we're only going to be dealing with angles in standard position. Now, what does standard position mean? Standard position means that the initial side of an angle, okay, which is the side that the angle starts on, is on the positive x-axis, okay? And its terminal side, well, it can be anywhere. Additionally, standard position means that the vertex of the angle, so that the corner, okay, is at the origin. Okay. Now, normally for angles, theta is common. We might use other Greek letters though. Alpha is common, beta is common. Usually we're going to be using theta though for the most part. Now, the standard convention for angles is the following. So if you rotate counterclockwise, this is what we call a positive angle, or we'll measure whatever units we're using, it'll be a positive measure. Now, if you rotate clockwise, like this angle, we would consider this a negative angle. Okay, so again, counterclockwise is positive, clockwise is negative. Anti what you might think. So here's some examples. So this right here would be about 45 degrees. This is 90 degrees. Here's about, now this isn't perfect, this is about 120 degrees. And again, notice that we're rotating counterclockwise in each one of these angles here. So we would have a positive measurement. Now the two examples below here, we're rotating clockwise. So we have negative measurements here. So this would be negative 90 degrees, and this would be negative 135. Now, I've been using degrees up to this point because hopefully everyone's mostly comfortable with that. But remember, there's two ways we can measure angles. Okay, we can either measure them in degrees or radians. Okay. Now, what I recommend for you all, get comfortable with radians, because radians is usually what other sciences use, and you'll see it in other classes. But remember, there's always a way to go back and forth, which we'll talk about in a second. In any case, what I want you guys to think about, degrees, the reason what degrees sort of measure, they sort of measure rotation. Okay, so 1 degree you can think of as 1/360th of a rotation around a circle. Now, radians, on the other hand, they're measuring, you can think about them as measuring arc length. Okay, so 1 radian you can think on the unit circle at least, which we'll talk about later. 1 radian would be this arc length right here. Okay, so radians you can think about as more of the arc length side, and then degrees rotation. Okay, but notice they are measuring essentially the same thing though. Okay, just just giving it a different perspective. Now again, you want to be comfortable with both. In particular, I would recommend getting comfortable with radians. And so it's important to know how to convert. Okay, so if you want to go from degrees to radians, what you would do is you would multiply by pi over 180. Multiply by pi over 180. So let's say we had 45 degrees, which we'll see in a second. If I want to convert that to radians, I would multiply by pi over 180. Now, if you're going the other way, if you want to go from radians to degrees, you multiply by the flip, 180 over pi. Okay, and we'll see examples of that below. Okay, so again, just to summarize, going from degrees to radians, multiply by pi over 180. And if you're going from radians to degrees, multiply by 180 over pi. All right, so let's look at some examples. So for instance, let's say we're starting with 45 degrees. If I want to convert this to radians, I'm going to multiply by pi over 180. Okay, and let's simplify that as much as possible. Notice that 45 goes into 180 4 times. Okay, so we would be left with pi over 4 in this case. 60 degrees, let's say we want to convert this to radians. Again, we're going to do the same thing. Multiply by pi over 180. Okay, now 60 goes into 180 3 times, so we would be left with pi over 3 in this case. Okay, now what if we want to go the opposite way? So pi over 6. So again, if I want to take this, which is in radians, and notice here, you know it's in radians because I don't have that little degree sign anywhere. And there's a pi, but although you could talk about pi degrees though, so that's not, it could be a red herring. But more importantly, there's no degree symbol, so I know this is in radians. Now, if I want to go from radians to degrees, again, what we do is we multiply by 180 over pi now. Okay, so in this case, the pi's cancel out. 6 goes into 180 30 times. Okay. Oops, and I forgot my degree symbol. All right, so pi over 2. Again, let's say we wanted to convert this to degrees. So I'm going to multiply by 180 over pi. Again, the pi's cancel out. 2 goes into 180 90 times. So this would be 90 degrees. Pi over 2 is 90 degrees. And then lastly, 2 pi. Well, second to lastly. Again, we're going to do the same thing. Multiply by 180 over pi. Pi's cancel out. And now we have 2 times 180, which is 360. So 2 pi is 360 degrees. Okay. Now, if you're dealing with a negative angle, same thing applies. Nothing's really changing. So let's say we wanted to convert negative 2 pi. What would happen? Well, we do the same thing. Okay, if we're going from radians to degrees, multiply by 180 over pi. Pi's cancel out. And you just bring or carry the negative sign over. So this is negative 2 times 180, which is negative 360 degrees.